Welcome back. So I hope that you did the exercise, and now to find the final k part for this total v1 cross v2, what you do, you cross out this row and this column, and that's your remaining 2 by 2 matrix, which is here. And then what you do, you take the determinant of it, and now you put the k unit vector here, but now it's positive, just like in the I case, only j was negative. And so that's your final answer, and let's call it C. That's your k component of this total cross product. And so the cross product v1 cross v2 equals, you have A, which was the I component, then minus B, and then you had the j component, and then plus C, which was the k component. And you know how to get your A, B, and C from those remaining 2 by 2 matrices that you had. And don't forget, in the j case, you had a minus here. And so if you have numbers for these elements here, 3 elements for v1 and 3 elements for v2, if you have numbers for them, then through this entire procedure that we had gone through, you will find some kind of numbers for A, B, and C. Let's say that A equals 5 and B equals 6 and C equals 7. Well, then your cross product would be 5i minus 6j and plus 7k. Or you can write it down like this if you want. Or if you want, you can draw it right here, where these are your 3 components. And so you have 5 in the x direction, minus 6 in the y direction, and 7 in the z direction. And then the vector itself would look something like this green arrow that is composed of those 3 components. And minus 6 was this one here for the y component. So this green vector here would be your v1 cross v2, all right? And a very important thing that you need to remember is that this vector that you get when you cross those 2 vectors, this green vector is perpendicular to v1 and v2. And so that's how you compute it mathematically. That's the procedure that you get from linear algebra. And so in the next video, we're going to talk about some of the applications of cross products. Thank you very much, and see you there.